Welcome back to Math with Rhyme or Reason. Just want to do one more video that does a few more practice on the solving radical equations because like I said, they get really mucky really quickly. So I'm just going to start with one similar to, well, I'm going to do 4 or 5 like the last two that I did on the exam on the previous video. So the first one I'm going to do is root x minus 4. Is equal to 2 plus root x. Okay, so here we go. Now this one is as isolated as I'm going to get it. I'm going to have to square first straight away. So that's where I'm going to start. I'm going to square both sides. Okay, making sure that I'm going to FOIL that side. All right. So on this side, the square root and square undo each other. They're inverse functions. On this side, I'm going to go ahead and square it out again. Got a lot of 4s here. All right, so 2 times 2 is 4, plus 4 root x. Oops. Plus x. Oh, this one's interesting. Okay. Now I'm going to subtract the x from both sides and the 4 from both sides. Don't get lost, that doesn't mean 0. The x minus x is 0. 4 minus 4 is negative 8 is equal to my 4 root x. Okay, and now I'm going to square both sides again. Okay, on the left side I get 64. On the right side, I get 16x. So I need to divide both sides by 16. And I'll get x equals 4. I'm going to plug it back into the original and see if it works for me. So 4 minus 4 is 0. Don't panic. You can square root 0. The square root of 0 is 0. So that's fine. Okay. And on the right-hand side, I will get 2 plus the square root of 4, which is 2 plus 2, which is not 0. However, pretty sure again that's extraneous because if this was 2 minus 2, I'll move that up so I can ask. If this was 2 minus 2, it would be 0, but it's 2 plus 2. So definitely extraneous. All right, so this is another one that has no solution. Put a big X through it if you like. Okay, let's do another one. This one we will do the square root of 2x minus 1 is equal to the square root of x minus 4 plus 2 plus 2. So on this one, it's as isolated as it's going to be, so we're going to square both sides straight away. And again, like I said, I'm going to want to FOIL that, so I'm just going to rewrite it right now. Oh, it's x minus 4. There we go. Okay, on the left-hand side, the square root and square undo each other. On the right-hand side, FOILing everything out gives me x minus 4. Plus 2 root x minus 4 plus 2 root x minus 4 is plus 4 root x minus 4. And then the 2 times 2 is plus 4. Okay. Now in this case, the minus 4 and plus 4 add to 0. So that's kind of nice. And I'm going to subtract the x from both sides. So that gives me x minus 1 on this side. And on this side, I'll get 4 root x minus 4. All right, I need to square both sides again. Now on the left side, I'm going to need to FOIL that out. On the right-hand side, I'm not foiling that side because there's no plus or minus here. So that means I just need to square everything in the brackets. So on this side, when I FOIL it out, I should get x squared minus 2x plus 1 equals 16 times x minus 4. And I'm going to need to multiply that out anyway, so I'm going to go ahead and do that. Okay, and like I said, I like my leading term on quadratics to be positive, so I'm going to subtract the 16x and add the 64 to both sides just to keep this guy positive. Okay, so I have x squared minus 18x plus 65 equals 0. So that factors to x minus 5, and x minus 13 equals 0. All right, so I'm going to erase things again. Now I need to keep my original so that I can check for extraneous roots. And in fact, what I'm going to do is I'm going to get rid of all the extra stuff that I added to it so that when I check the extraneous root, I'm checking it back into the original equation instead of into the things that we added. All right, so that was the original equation. So if I have two numbers that multiply to 0, so either this bracket is 0, in which case x is equal to 5, or this bracket is 0, in which case x is equal to 13. Okay, so now I need to plug those back into my original equation. So if I plug in 5, I get 2 times 5 is 10, minus 1 is 9. 5 minus 4 is 1, plus 2. So I get 3 is equal to 1 plus 2. That works. 5 is good. Okay, I'm going to do the same with 13. 13 times 2 is 26. Oh, I'll do it in a different color so that you know which one I'm doing. Okay, so that'll be 26 minus 1 is 25. And 13 minus 4 is 9 plus 2. So that's 5 is equal to 3 plus 2. And that works too. So both are possible solutions. Okay, I'm going to do one more of these that has a bunch of radicals in it. By the way, I didn't show it, but on one of the outtakes on this video, I made a mistake. And so when I was checking it back into the original, I ended up with like the square root of 27 and the square root of 5. I was pretty sure I'd made a mistake. That's an example of what happens when you made an algebraic mistake versus an extraneous root mistake, is you end up with complete nonsense in your numbers. Okay. All right, let's do one more example, and then we'll let you practice on your own. All right, and the last one I'm going to do is, this one has a lot of 3's in it instead of 4's. 3 minus 3x, and the square root sign, equals 3 plus root 3x plus 2. Okay, so the first thing I'm going to do is square both sides, making sure I FOIL out the right-hand side. So I'm going to write it again. Okay, the left-hand side, the square and square root undo each other. The right-hand side, 3 times 3 is 9, plus 3. Square root 3x plus 2 plus 3. Square root 3x plus 2 is 6. Root 3x plus 2. And then this guy times this guy is 3x plus 2. Okay, and again, I'm going to get everybody over onto my left-hand side in this case. So I'm going to subtract the 3x off of both sides. That will give me negative 6x on this side. I have 9 plus 2 is 11, which I'm going to subtract, so 3 minus 11 is negative 8, and that's equal to the right-hand side still. Okay, I'm going to square everybody out. Alright, so that's 36x squared. 48 and 48 is 96x and 64. And on this side, I'm going to get 36 times 3x plus 2. Now, because I'm doing this in front of you, I want to simplify my math out quite a bit. So I'm going to divide everybody through by 4, and that's just going to keep my math easier. You don't have to do that step, but like I said, I'm doing this without a calculator in front of me, so hopefully I can keep up with the math. All right, so I'm dividing everybody through by 4. So that'll be 24, that'll be 16, and that'll be 9 times my 3x plus 2. And I'm going to go ahead and multiply that out too. 27x plus 18. Okay. Now, like I said before, I'm going to subtract to keep this guy positive. That'll give me 9x squared. Subtracting the 27x is minus 3x. And subtracting the 18 is minus 2 equals 0. And again, I'm going to run out of room, so I'm going to go back and erase some of this. Again, keeping my original equation so that I can check it for extraneous roots after. All right. Oops. Let's get rid of this. All right. So I need two numbers that multiply to negative 18 and add to negative 3. So those would be 6 and 3. So I'm factoring is what I'm doing here. So that's a factored version of that. So now I'm going to get rid of the rest of this to finish off my equation. Alrighty, so if this is equal to 0, then x is equal to negative 1/3. If this is equal to 0, then x is equal to 2/3 are my two possible solutions. By the way, if that confused you, all I'm doing is you can actually solve for, I'll do it over on the side here. 3x plus 1 equals 0. Subtract 1 from both sides and divide by 3, then x equals negative 1/3. Okay, just in case you're having a little trouble solving the linear algebra for it. Okay, so my two solutions are x equals negative 1/3 or x equals 2/3. Now I'm going to check and make sure that they work back into the original equation. So I'm going to check this one first. So if I plug in negative 1/3, I get 3 plus 1 is the square root of 4 equals 3 plus negative 1/3 times 3 is negative 1 plus 2 will be root 1. So I get 2 is equal to 4. That's not a solution, but again, I'm pretty confident about the extraneous part because if that was 3 minus 1, then that would equal. So this guy's extraneous. And we're going to check the other one too. So this is the 2/3. So 3 minus, plugging in 2/3 times 3 is 2. 3 minus 2 is square root of 1. Oops. Let's just leave it like so. All right, equals 3 plus 2/3 times 3 is 2. 2 plus 2 is 4. Square root of 4. So I get 1 is equal to 3 plus 2. Again, that's not true, but again, I'm pretty confident about the extraneous because if it was 3 minus 2, it would equal 1. So this one's also extraneous. So this equation has no solution because both of the answers are extraneous. Okay, that concludes my radical math series. Hopefully that sorts out everything, and hopefully doing the extra examples helps you out too. Join me next time when we talk about parabolas. See you soon. Okay.